VTP is a synchronization protocol. It's a replication protocol, and we're replicating a VLAN database. How do we know that we're getting new information? Well, to think and understand how we get new information, we have to look at dairy products. And when we understand how dairy products are encoded with a freshness date, or maybe you've got a beverage, maybe it's an alcoholic beverage, and you have a born-on date, that same system is applied to VTP. And we call that value a configuration revision number. A configuration revision number. Now I've got a switch rebooting in the background. I'm going to go to a different switch, and I want you to see this configuration revision number. Show VTP status. That's really the key command for our equipment. The configuration revision number of 2. Okay. Is this other switch got that? Looks like I can get in now. Good. Show VTP status. Configuration revision number of 2. Whoa. There's something going on here. There is a synchronization that must be taking place of some kind, as I see that number match on both devices. Think to buying food. If you see a better date, a date that's higher, closer to you, or further out, actually, if it's dairy, that means that it's newer information. So here's how this really works. If I go to a server and I make any change, that change bumps up the current revision number by 1. So if you're a programmer, think rev plus plus, okay? Or plus plus rev, however you want to do that. Add 1 to the existing value, and then advertise that change over your trunk links. It's always over your trunk links. Advertise that change over your trunk links, and receiving switches will see that. Now, what they're going to do is they're going to look at the advertised value. The advertised configuration revision number was 4. Now, if they had all synchronized before, they would have had a revision number of 3. So upon receipt of this 4, and I've got a 3, that's better, that's higher. And so whatever's in there, and by the way, this is not an incremental update. This could be a massive change. We could have just erased everything. We'll believe any advertisement that has a higher revision number. And so we sync to the new information. Now notice that we made a change on a server and another server gobbled that up. Get it out of your head if you have it in there. I know from past experience that a lot of students say, oh, you can only have one server and servers don't listen to other servers. No, no, no. In fact, there are really only 2 fundamental differences between servers and client mode switches. Clients disallow the command, the VLAN command. That's change number 1. Change number 2, they don't store their VLANs or read their VLANs in VLAN.dat. When they come up fresh, they have to learn from devices in client mode. That's really the only behavior. Okay? So only behavioral changes. So servers talk to clients. Clients will also gobble that up. But would a transparent mode switch adapt to that change? And the answer is no. They do things themselves. And if you're on a transparent mode switch, the revision number stays as 0. Absolutely right. That's a great way to zero out the revision number if you want to. Make it transparent and boom, you just change that value, regardless of wherever it was, down to 0. That's a useful little tip. And in fact, let's test that right now. VTP mode transparent. Do show VTP status. Now, before I did that command, my revision number was 2. Do you believe me? Is it going to be 0 now? Of course you believe me. No, you can actually, second guess me. I don't mind that. but it's 0. Great. So what we're learning holds true, and this behavior is really significant. Oh, by the way, let's watch the revision number bump up and increment, shall we? I think that's important behavior as well. So let's go over to DSW1, show VTP status, include, great, VLAN, say no VLAN 2. I think actually that's a VLAN. So I'm going to up arrow. So I'm going to just copy that. Okay, so I just made a change. Let's add VLAN 2. Bumped up to 3. What if I name VLAN 2? Oops. There we go. So even a name change is going to bump up the revision number. What if I add 300 VLANs, or not 300, but an extra 101? I just added a large number of VLANs, and in order to make that change, it only took one advertisement and one update. What I wanted to prove to you there is the fact that one small revision change can have sweeping changes. For instance, I could literally say no VLAN 2 through 4094. Can't get rid of a few of them. But now, I'm back at the default, and all it took is one change, one command, to blow away more than 100 custom defined VLANs. This is a very powerful protocol.